Question 9, Part B. During a storm, water flows into a 7,000 litre tank at a rate of dVdt litres per minute, where dVdt equals 120 plus 26t minus t squared, and t is the time in minutes since the storm began. Part 1. At what times is the tank filling at twice the initial rate? The rate of flow is given by dVdt equals 120 plus 26t minus t squared. So let t equal 0 to find the initial flow rate. So we want to evaluate dVdt when t equals 0. So dVdt equals 120 plus 26 times 0 minus 0 squared. So the initial flow rate is 120 litres per minute. Hence, twice the initial flow rate is 240 litres per minute. So we want to solve for t the equation dVdt equals 240. So we want to solve 120 plus 26t minus t squared equals 240. So rearranging this equation to turn it into a monic quadratic equation, move the 240 from the right hand side over to the left hand side, it becomes negative 240. Combining that with positive 120, we get negative 120 plus 26t minus t squared equals 0, multiplying all terms by negative 1. To make the t squared positive, we get t squared minus 26t plus 120 equals 0. Now the left-hand side factorizes to t minus 6 in brackets times t minus 20 in brackets equals 0. Alternatively, you could use the quadratic formula. And we get solutions t equals 6 or t equals 20. Therefore, the tank is filling at twice the initial rate at times t equals 6 minutes and t equals 20 minutes. Part 2. Find the volume of water that has flowed into the tank since the start of the storm as a function of t. The volume V is given by the integral of the flow rate dV/dt with respect to t. So the volume is equal to the integral of 120 plus 26t minus t squared dt. Performing the integration, we get V is equal to 120t plus 13t squared minus 1 over 3 times t cubed plus c, where c is a constant. Part 3. Initially, the tank contains 1,500 litres of water. When the storm finishes, 30 minutes after it began, the tank is overflowing. How many litres of water have been lost? From part 2, the volume of water V in the tank at time t is given by V equals 120 times t plus 13 times t squared minus 1 over 3 times t cubed plus the constant c. Before we can proceed any further, we need to find the value of the constant. We can apply the initial condition to do that. We know that at time t equals 0, the volume of water in the tank is 1,500 litres. So substituting 0 for t and 1,500 for V in the equation, and then solving for C, we get 1,500 is equal to 120 times 0 plus 13 times 0 squared minus 1 over 3 times 0 cubed plus C. So we get C is equal to 1,500, since this part of the expression here is equal to 0. So the volume V is given by 120 times t plus 13 times t squared minus 1 over 3 times t cubed plus 1,500. Now after 30 minutes, the volume V is equal to 120 times 30 plus 13 times 30 squared minus 1 over 3 times 30 cubed plus 1,500, which equals 7,800. But the tank can only hold a maximum of 7,000 litres. Therefore, 800 litres of water is wasted.